नमस्कार बच्चों, आप सभी का मैं इस जीनियस साइंस यूट्यूब चैनल पे सबसे पहले हार्दिक स्वागत करता हूँ। हम यहाँ पे आज जो नया टॉपिक लेकर आए वो है डिफरेंशियल इक्वेशन, that is derivatives of composite functions. We shall discuss or we shall study here the derivatives of a composite function. In the last lecture we have seen that the derivative of composite function, how to calculate the derivative of composite function in the form of logarithmic function, in the form of log, which is included a complication of terms, that is in multiplication, division. Today also we shall discuss how to calculate the derivative of functions that are also in the logarithmic form. Yesterday we have seen that the formulae for different formulae for the derivatives of composite functions. Now, how to take the derivatives of composite functions? First of all, I change the pen here, color of the pen. Yes, okay. Now, this formulae which we have studied, the formulae for the composite functions which are similar to the formulae for the simple functions. Only difference is that replace x as a f of x, then we will get the formulae for the composite functions, and in that derivative we have to add extra term, that term is f dash of x. Means I is like, again revise, I is like the derivative of, here I is like this. Suppose derivative of x equals to, suppose x square equals to 2x or 2x raised to 1. In the composite form, replace a function f of x in place of x bracket square. Then how to calculate derivative? 2 into f of x bracket raised to 1 into again f dash of x. Such type of functions we have studied yesterday, and that are the composite functions. That is, replace x by f of x, we get a composite function formula. Here we have discussed yesterday. Now consider this example. Some examples also we have solved. Which type of that example? In the log there is a complication of or composition of different functions, algebraic functions. Then such a type of functions derivative can be obtained by simplification of logarithmic term. अगर log में 3-4 टर्म का कॉम्प्लिकेशन आता है, मल्टीप्लिकेशन, डिवीजन आता है, तो पहले डिफरेंशिएशन के पहले उसका सिंप्लीफिकेशन करना पड़ता है लॉगरिथमिक रूल्स के आधार से, और उसके बाद फिर से आफ्टर सिंप्लीफिकेशन वी कैन टेक अ डेरिवेटिव. नाउ कंसिडर दिस एग्जांपल here. We shall discuss here how to solve this example here. See here. Suppose this is a problem, y is equals to log of 1 minus cos 3x by 2 divided by 1 plus cos 3x by 2, which is included in the root, means log of root of 1 minus cos 3x divided by 1 plus cos 3x. Our aim is to find the derivative of this term. How to calculate? Now, first of all, we have to simplify these terms. We cannot find out directly derivative of this term. Therefore, before finding the derivative or before differentiating with respect to x, first of all simplify this term which is in log. Now keep this root as it is, log as it is. What is the formula for 1 minus cos 3x by 2? Use the formula 1 minus cos theta. What is the formula for this? 1 minus cos theta means 2 into sin square theta by 2. This is the formula for 1 minus cos theta. Here we have used a 1 minus cos 3x by 2. Consider this 3x by 2 means 2 sin square 3x by 4, because theta by 2 means here 3x by 2 upon 2 means 3x by 4. Similarly, 1 plus cos theta means we have to use another formula. 1 plus cos theta is equals to 2 into cos square theta by 2. Okay. Then this is the formula for trigonometric functions, 1 minus cos theta upon 1 plus cos theta. Now this 2 get cancelled. Sin square theta upon cos square, that angles are same. Therefore, sin square theta upon cos square theta means tan square theta, and tan square which is in square root. Therefore, tan square and tan get cancelled. That is like this, tan square 3x by 4. The square and root gets cancelled. In the log, we get only tan 3x by 4. This is a tan 3x by. This is the simplification in log by using the trigonometric formula or trigonometric identity. Now we can differentiate this. This is the simple form. Then we cannot take another simple form in log. Therefore differentiate this. अब इसका differentiation करते हैं. Y का differentiate with respect to x is dy by dx equals to derivative of log I is it is tan 3x by 4. Now what is the derivative of log? If there is a log of f of x, then its derivative is 1 upon f of x in again derivative of f of x. पहले log का differentiation ले लो. log का differentiation बोले तो 1 upon रहता है 1 upon tan 3x plus 4 into again this is a composite function, therefore we have to take again derivative of tan 3x plus 4, which is equals to 1 upon tan means cot 3x by 4 into derivative of tan is sec square 3x by 4. This is the derivative of tan. Again this is a composite function, there is no tan x, tan 3x by 4. Therefore derivative of tan is sec square 3x by 4 as it is. Again we have to take derivative of 3x by 4, derivative of 3x by 4. This cot 3x by 4 can be written as cot means cos upon sin into sec square means 1 upon cos square, put this angle as it is, into now derivative of 3x by 4, 3 into 3 is a constant coefficient, derivative of x is 1, 3 into 1 means 3 by 4. This is the total differentiation process. Now we can solve here simplification method or simplification procedure. Hereafter we have to simplify. Cos divided by sin, here cos square 1 upon cos square. Therefore this cos square and this cos get cancelled. Put 3 as it is in the numerator, 4 here, then sin 3x by 4 into cos 3x by 4. This 4 can be split 2 into 2. Here we have to use denominator formula 2 sin theta into cos theta. We can write 2 into sin theta into cos theta. We can write 2 sin 2 theta. Therefore by using this identity 2 sin theta into cos theta, sin 2 theta, 2 there is not, this 2 as it is, 2 into sin theta into cos theta means sin 2 theta. Therefore sin of 2 theta, theta is 3x by 4, therefore it's double 3x by 2. Therefore numerator 3 as it is, 2 into sin 3x by 2, 1 upon sin means cosec. The result is dy by dx equals to 3 by 2 cosec 3x by 2. Here in this case, for a capital bracket, we have used a formula here, 2 sin theta into cos theta is equals to sin 2 theta. Okay, this is the solution of one of the example. Now we shall discuss another example which is in the relation और which is in this type. यहाँ पे हम इसका एक दूसरा और another example consider लेते हैं जिसके वजह से you can confirm this example. तो discuss this. Suppose y is equals to, we can take first pen, change pen कर. हाँ कसं काय ना mouse na 1 minute, we have to change this. Okay, see here, consider this example. Suppose y is equals to log of, same example, square root of 1 minus cos 3x divided by 1 plus cos 3x. Now before differentiation we can simplify this in the square root. Use a formula, 1 minus cos theta means 2 into sin square theta by 2. Sin square theta by 2 means 3x upon 2 divided by 1 plus cos theta means 2 into cos square 3x by 2, because 1 plus cos theta, formula for 1 plus cos theta means 2 into cos square theta by 2. This 2 get cancelled. Log of square root of sin square divided by cos square means tan square 3x by 2. Again this square and root get cancelled. Log of tan 3x by 2. This square and root get cancelled. This is a simplified y. Now hereafter we can differentiate with respect to x. Differentiating with respect to x. Therefore derivative of y is dy by dx. We can take first step directly. What is the derivative of log? Derivative of log f of x equals to 1 upon f of x into derivative of f of x means 1 upon tan 3x by 2 into derivative of tan 3x by 2. Now put this value as it is, 1 upon tan 3x by 2 into derivative of tan 3x by 2 is sec square 3x by 2. Again we have to take derivative of 3x by 2 is 3 by 2. We have used a direct step here, that is equals to 3 into sec square 3x by 2 upon tan 3x by 2. Okay, tan means actually 1 upon quat, or we can put this result as it is, or you can simplify in terms of sin and cos also. This is not so hard, therefore you can extend this problem or keep it as it is. You can convert this hereafter sin and cos and cancel some of the terms, and let's put it as it is. Okay, right on. Next we shall discuss the another example. What is that example here? Suppose y is equals to log of root 1 minus sin x divided by 1 plus sin x. Now again log of root 1 minus sin x divided by root 1 plus sin x. We can write 1 minus sin x divided by 1 plus sin x whole to the power 1 by 2. This root shifted into its fraction power 1 by 2. Log of m bracket raised to n, then we can simplify 1 by 2 log of 1 minus sin x. Now, for log m divided by n, then we can write log m minus log n, that is 1 plus sin x. Put it as it is, that is 1 by 2 log of 1 minus sin x minus 1 by 2 log of 1 plus sin x. These are the steps of simplifications. Hereafter we can differentiate. Therefore, differentiating with respect to x, dy by dx equals to 1 by 2, keep as it is. Derivative of log of 1 by sin x means 1 upon 1 minus sin x into, again this is the derivative of log, means 1 upon 1 minus sin x. Again we have to take a derivative. We can take directly. What is the derivative? That derivative of 1 is 0, minus as it is derivative of sin x is cos x, minus 1 by 2, again derivative of log of 1 plus sin x. First of all take derivative 1 upon 1 plus sin x into derivative of 1 plus sin x is cos x. Derivative of 1 is 0 and derivative of sin x is cos x. Now again we shall solve this. Therefore, dy by dx equals to minus cos x divided by 2 into 1 minus sin x minus cos x divided by 2 into 1 plus sin x. Take out a common, minus cos x divided by 2 is the common term. What are the terms remaining in the denominator? 1 upon 1 minus sin x plus 1 upon 1 plus sin x, that is equals to minus cos x divided by 2 into, now take a multiplication, cross multiplication, 1 plus sin x plus 1 minus sin x divided by a minus b, a plus b means 1 minus sin square x. This plus sin x minus sin x get cancelled. That is equals to, what are the term? Minus cos x divided by 2 into 1 plus 1 means 2 divided by 1 minus sin square x means again cos square x. That is equals to, this cos x cos square term cancel, 2 get cancelled, minus 1 upon cos x. The final answer is minus sec x. This is the dy by dx. Thus we can find the derivative of log of 1 minus root 1 minus sin x divided by 1 plus sin x. First of all, we have converted this root into its index 1 by 2 by logarithmic formula log of m raised to n. This is in product, and due to the division we can take subtraction in log and then calculate or simplify. These are the simplification step from first to this, and then differentiation. Okay. Next, thus we can find the derivative of such types of logarithmic functions, logs. Okay. Next, we shall study another example, which is the critical example, which is a tough example, which is included in log. So we shall discuss this example here. This is again tough example here. Suppose y equals to log of x plus root x square plus a square divided by x square plus a square minus x. Now our aim is to find out the derivative of this y, that means dy by dx. We cannot find derivative directly in this step. As like a previous example, we have to simplify this. Now this is a plus root is like root term and minus root term. Then we have to rationalize this. Rationalize this means we have to change or divide and multiply by the denominator's conjugate. That means divide and multiply by denominator's conjugate. This is a denominator, therefore its conjugate is this. Divide and multiply by x square plus a square plus x, root of x square plus a square plus x. Divide, multiply. Now use the formula. In the product, numerator, two brackets are same, therefore this bracket and this brackets are same, therefore we can write bracket square. Root of x square plus a square plus x bracket square divide by, in this case in the denominator we have to use the formula a minus b, a plus b. A minus b, a plus b means a square minus b square. A square minus b square. Therefore, this is a log of root x square plus a square plus x bracket square minus, if there is a division in a log, then we can convert this into the subtraction. This is a minus b, a plus b means a square, root cancel, b square means x square, again this x square get cancel, a square is in the denominator, m divided by n, log of m minus log of n. Again this index, by using a logarithm formula we can take in the product form, therefore y is equals to 2 log of root x square plus a square plus x minus log of a square. This is the complete simplification of given problem. Now hereafter we can differentiate this, therefore differentiating with respect to x, dy by dx equals to derivative of right side. Again 2 is the constant coefficient, keep as it is, derivative of first term this, derivative of second term this, because in the subtraction we can take derivative separately. अगर subtraction है तो derivative हम separate ले सकते हैं. Now this step is important. First of all differentiate by log. What is the derivative of log? 1 upon f of x. This is a 1 upon f of x into again derivative of this function. Now in second part this is a completely constant term, therefore derivative of constant term is 0 because there is absence of x. Due to absence of x we can say this is a constant, derivative of constant is 0. Now 2 upon this term as it is. Now again we have to take derivative. What is the derivative of root? First time we have to take derivative of root. Derivative of root is 1 by 2 root x square plus a square as it is. Again this is a composite function, therefore we have to take a derivative of x square plus a square plus x. तो इसमें क्या है, डेरिवेटिव अगर रूट का 1 अपॉन 2 रूट एक्स स्क्वायर प्लस ए स्क्वायर इंटू डेरिवेटिव ऑफ एक्स स्क्वायर प्लस ए स्क्वायर प्लस दिस इज अ सेपरेट टर्म एक्स, डेरिवेटिव ऑफ एक्स इज 1. नाउ दिस टर्म as it is keep 2, derivative of x square is 2x, this one is again as it is, remaining terms are same. Now 2 upon this term, here 2 get cancel, x upon रूट एक्स स्क्वायर प्लस ए स्क्वायर प्लस 1, यहाँ पे x अपॉन रूट एक्स स्क्वायर प्लस ए स्क्वायर प्लस 1 ऐसे फैक्टर होते हैं. तो फिर इसका एलसीएम निकालने के बाद इसका डिनोमिनेटर कुछ नहीं बोले तो 1, देयरफॉर द नेक्स्ट स्टेप ऑफ दिस दैट इज एलसीएम x प्लस रूट एक्स स्क्वायर प्लस ए स्क्वायर डिवाइड बाय रूट ऑफ एक्स स्क्वायर प्लस ए स्क्वायर. दिस इज अ टर्म ऑफ अ ब्रैकेट. यहाँ पे 1 है, 2 गेट कैंसल, एलसीएम निकालने के बाद ये आता है. अगेन दीज 2 टर्म्स आर सेम, देन द रिमेनिंग टर्म 2 डिवाइड बाय एक्स स्क्वायर प्लस ए स्क्वायर. ये थोड़ा क्लिष्ट और कॉम्प्लिकेटेड प्रॉब्लम है, यू कैन वेरीफाई for one time, 2 time and solve this problem because ये ज़्यादा हार्ड है, थोड़ा बुक में थोड़ा ये ज़्यादा टिपिकल प्रॉब्लम है, इसलिए मैं इसका एक्सप्लेनेशन कर दिया यहाँ पे. आप इसको 1-2 बार रिवाइज कर सकते हैं और सॉल्व कर सकते हैं. कुछ प्रॉब्लम है तो यू कैन आस्क. नेक्स्ट वी शैल सी another example related to this example. Now we can solve problems based on the logarithmic function. See here, okay. Now we shall solve another examples related to this. Suppose that log of y equals to log of y equals to log of, you can take suppose a raised to cos x divided by x square plus 3 bracket cube into log x. Y is equals to log of a raised to cos x. Due to this division we can take a subtraction, log of x square plus 3 bracket cube into log x. Solve this. First of all, you can take a simplification. Y is equals to cos x into log a minus log of x square plus 3 bracket cube. Again there is a product. In the product, log of m into n, then we can write log of m plus log of n. Due to this minus, we can write minus log of log x. Therefore, y equals to cos x into log x minus 3 log a minus 3 log of x square plus 3 minus log of log x. Now this is a total simplification. Therefore, differentiating with respect to x, dy by dx equals to, this log a is a constant coefficient, derivative of cos is minus sin x into log a minus this 3 is a constant coefficient, derivative of log is 1 upon x square plus 3 into again derivative of x square is 2x and derivative of log x is 1 upon log x into again second log x 1 by x. Therefore, the final answer is minus sin x into log a minus 6x divided by x square plus 3 minus 1 upon x log x. Such type of logarithmic problems you can solve continuously. If you are in a difficulty, then you can ask. Now we shall discuss this problem. See here. Okay. Now we shall discuss how to solve the another example. Suppose y is equals to, now we shall discuss this type of a problem. Y is equals to 4 raised to log of here you can take this y is equals to 4 raised to log of sin x to the base 2, 9 raised to log of cos x to the base 3. We have to use दिस टाइप ऑफ एक्सपोनेंशियल फंक्शन, ये नया टाइप का प्रॉब्लम है। एक्सपोनेंशियल फॉर्म के कंपोजिट फंक्शंस है जिसका बेस कांस्टेंट है और इंडेक्स लॉग में है। तो वी कैन सॉल्व दिस। 4 can be written as 2 square, again put index as it is. 9 can be written as 3 square, again index as it is. Therefore, here we have to use formula a raised to m bracket raised to n, there gives a result a raised to m into n. Okay. Therefore, we can write this 2 into log of sin x to the base 2. Here 3 square its power log 3 cos x is 2 into log of 3 log of cos x to the base 3. Again this is in product form, we can transfer into the index. Therefore, 2 raised to log of sin square x to the base 2. Again this 2 transfer into the index, log of cos square x to the base 3. But here we have to use this identity which is used in the logarithmic formula, a raised to log of f of x to the base a. इसका अर्थ ये बेस में है, इसके इंडेक्स में लॉग है और उसका अगेन बेस ये है, तो बोथ टर्म गेट कैंसल, द रिमेनिंग टर्म इज ओनली एफ ऑफ एक्स. देयरफॉर 2 raised to log to the base 2, this is the inverse of each other, that goes to 1 and remaining term is sin square x. This is also like cos square x, okay, and sin square x plus cos square x is 1. This is the complete simplification. Now we can differentiate this, and by the differentiation we can write derivative of y is dy by dx and derivative of 1 is constant, which is equals to 0. Okay. Now let us see another example based on this type, that means exponential function in terms of logarithmic form. Consider another example. See here, we shall discuss another example based on this. Suppose y is equals to y equals to 25 raised to log of sec x to the base 5 plus minus 16 raised to log of tan x to the base 4. Now we shall write this problem again. Y is equals to 25 raised to log of sec x to the base 5 minus 16 log of tan x to the base 4. Now actually here base of the log is 5 and base of this exponential term is 25. Therefore, convert this 25 into its index form as 5 square its power log of sec x to the base 5. Here also in the index there is a log whose base is 4. Therefore, convert this 16 into index form of 4, that is 4 square again log of tan x to the base 4 as it is. Now m raised to n bracket a raised to m bracket raised to n, then we can write a raised to mn. Therefore, 5 raised to 2 into log of sec x to the base 5 minus 4 raised to 2 into log of tan x to the base 4, that is equals to 5 raised to log of sec square x to the base 5 minus 4 raised to log of tan square x. This product transfer into index form, base size it is 4. Now here we have satisfied the formula. What is that formula? A raised to log of f of x to the base a, then both terms get cancelled, remaining term is f of x. Therefore 5 log to the base 5 cancel. Here is a sec square x plus tan square x, and sec square x plus tan square x is equals to 1. This is the simplest form of given problem. Then we can differentiate with respect to x. dy by dx equals to, here is a minus sec square x minus tan square x is 1. Therefore differentiating with respect to x, derivative of 1 is 0. This is the final answer, because this is minus, keep this minus as it is, and sec square x minus tan square x is equals to 1. Okay, this is the complete answer of this. Next, okay, now we shall discuss new types of problem. Suppose a raised to a here, this type problem. Okay, now here we shall study this another type of problem. What is that? Y is equals to a raised to log raised to a quat x. If we discuss the formula for exponential including log whose base is again a, then this a and this a will get cancelled. What is the remaining term? Only quat remaining term as it is. This index a is it is here. A raised to log of quat x to the base a. In this case, put this as it is. In this case, a raised to log to the base a, that will be reciprocal of each other, cancel each other. Remaining term is quat as it is, means a raised to quat x. This is, thus we can write y is equals to a raised to quat x. This is the simple form. Differentiating with respect to x, dy by dx equals to a raised to quat x. As like formula a raised to f of x. What is the derivative of a raised to f of x? A raised to f of x into log a into f dash of x. Again we have to take a derivative of f dash of. In this way, a raised to quat x means a raised to quat x into log a, again derivative of quat x. What is the derivative of quat x? Minus cosec square x. Therefore dy by dx equals to minus cosec square x into a raised to quat x into log a. Why we have considered this example? Because here a raised to log means double exponential function, which we have given here in the form of log whose base is again a. Therefore this is a new concept which we have to study here. Therefore you cancel that term. ये आपको इसलिए मैं एग्जांपल कंसिडर किया कि इसमें डबल एक्सपोनेंशियल फॉर्म है, एक्सपोनेंशियल का एक्सपोनेंशियल है हुज एक्सपोनेंट इन टर्म्स ऑफ लॉग टू द बेस a. Okay, this is the total discussion of the problem. We shall discuss another examples if this type of example exists. Okay, you can take. Thank you. Now we shall stop here because the exponential function and logarithmic functions, this type is ended here. Now we shall start new type of problems in the form of a composite function tomorrow. Thank you.